right, trig functions of any angle. It says theta is an angle in standard position, and xy is a point on the terminal side of theta. So just for a visual, because I'm a visual person. Here's our x and y axis, or technically y, now x axis. And then our angle in standard position. So I'm just gonna, I'm gonna draw one, terminates in quadrant 1, just for here. So there's my angle theta. And it says a point on the terminal side from which a perpendicular is dropped, creating a right triangle. So here's my point on the terminal side, x comma y, perpendicular dropped, creating a right triangle here, whose hypotenuse is side r. So that would give us hypotenuse r based on that point xy. Horizontal length is x, vertical length is y. So we have a right triangle in terms of the variables x, y, and r. And here is how those 6 trig functions are defined based on that variable, or that triangle. All right, given that the point -4, -6 is on the terminal side of the angle theta, find the exact value of all 6 trigonometric functions of theta. All right, so I want to draw it, so I know where I am. All right, -4, -6, that is a point in quadrant 3, because they're both negative. So I know my angle terminates in quadrant 3, so there is the starting point. Ending ray, a little terrible label, but it'll work. Drop my perpendicular, creating this right triangle. Maybe it'll cooperate some. That's close. There we go. That looks a little bit better. All right, right triangle. Point was -4, -6, so that means this is -4. X, y is -6. So r can be found using the Pythagorean theorem. So in relationship to x, y, and r, here's your Pythagorean theorem in terms of x, y, and r. X squared plus y squared, because that's the sum of the squares of the legs, is equal to r squared. So r is that side of our triangle. R represents what we're fixing to come in is, we're calling it the hypotenuse. R is always going to be positive. The reason we're using the letter R is we're fixing to turn it into what's called a radius. A radius must be positive. So R will never be negative. Anyways, so R is going to be, if we solve for R, the sum of the squares of x and y square rooted. So that's your definition for R. All right, so based on my triangle here, the value of R is -4 quantity squared plus -6 quantity squared under a square root. So again, as much math as you need to show, you should be able to do this all at once. -4 squared is 16, -6 squared is 36, and then that gives us R is the square root of 52, and if we try to reduce 52, I believe divides by 4 nicely. So again, everything's got to be reduced form, so that is going to be 2 square root of 13. So there's our radius, or hypotenuse in this case. So now I'm going to come up here and just label R equals 2 root 13. All right, so the value of the 6 trig functions of theta, so that means all 6 of them. So I'll start with sine. So sine of theta is the y side over the hypotenuse, so that would be -6 over 2 square root of 13. Nothing's changed about our fractions, simplified, rationalized. So I'm going to move it up, drop it on the bottom. Over, I need my division bar to draw straight. 2 times 13. Reduce everything. -6 divides by 2, it's 3. So -3 square root of 13 all over 13. That's as simplified as we can go. Cosine is the x value over the r value, so that's going to be -4 over 2 square root of 13. Right, -4 over 2 does reduce, -2, I'm going to go ahead and reduce it, move the root up, and drop it on the bottom. So as far as simplifying however many steps it is you need. Tangent of theta. Tangent is the y side over the x side, so that would be negative 6 over negative 4. Negative negative is a positive. Reduce it, 3/2. Hey, look, we got a pretty one. All right, and then the 3 reciprocals. Sines reciprocal, cosecant, which is r over y. So r 2 square root of 13 over negative 6. Reduce. So root 13, a negative somewhere, over 3. Cosine's reciprocal is secant, S-E-C. Secant of theta is r over x. R 2 square root of 13, x negative 4. So 2 square root of 13 over negative 4. Reduce, we need a negative somewhere, root 13 over 2. And cotangent is the reciprocal of tangent, which would be x over y, so negative 4 over negative 6. Double negative makes positive, 2/3. All right, a quadrantal angle. A quadrantal angle is an angle that terminates on an axis. So you have a positive x, a negative x, positive y, and negative y. All right, example 2. Evaluate each. So sine of theta, sine of 0. So that's in radians. So if we think about, I'm going to put an axis here. Here is 0, it's here. So that ordered pair is, I don't know what x is, x comma, well, y is 0. Sine is y over r. Well, y is 0. 0 divided by something, it's 0. 0. Tangent pi halves. Pi halves is 90, straight up here. That point is 0 comma y. Tangent is y over x. So here's the problem. Y over 0, because I know x has to be 0. I am not allowed to divide by 0. That is a no-no. That is undefined. Cannot do it. Does not exist, undefined. I like D&E. 0 in the denominator is going to be a problem no matter what course you take. Does not exist. Tangent of pi halves does not exist. And then finally C, cosine 270. So we'll keep rotating through the colors. 270 is here. That is the point 0 comma y. So cosine is x over r. Well, I don't have an r, it's just x, 0. So quadrantal angles, angles on axes, you're going to have special forms of these values. We'll expand on it more in a little while. All right. Example 3, determine which quadrant the angle terminates in using the given information. So here I've got your chart with your sines. I don't memorize it because, again, that's one more thing I got to deal with. I just go through, I kind of play a game with myself. So it's called two's clues. You got 2 clues and we're trying to find the winner here. All right, so it says sine of theta is positive. Sine is positive. I want to scoochie you over here so I can go on each side. So sine positive. Sine is the ratio of y to r by our new definition, which must be positive. So r, I'll tell you now, r must be positive no matter what, because remember, it represents a radius. A radius cannot be negative. Well, if r is positive, in order to make this division, this ratio positive, I know that y must also be positive since r has to be. So if I look at my 4 quadrants, y is positive anywhere in quadrant 2 or in quadrant 1. So I'm looking at 1 or 2 right now. So just based on this information, I know we are in quadrant 1 or we are quadrant 2. Then I'm going to go to my other piece of information. Secant of theta is less than 0. Secant is the reciprocal of cosine. Cosine is x over r, so secant is r over x. So this ratio is less than 0. The only way this ratio is less than 0 is if one of these two is negative, not both, because both means positive. R is not allowed to be negative ever because it represents a radius. It's our hypotenuse, which means x has to be negative. So x has to be less than 0. So if I go play this game, x is less than 0, left. So x is less than 0 in quadrant 3 or in quadrant 2. And the winner is the overlap shading. Theta is in quadrant, that's not quadrant, quadrant 2. All right, next one. We play the same game. All right, tangent's positive. Tangent is the ratio of y to x. So there are two ways to get this ratio to come out positive. One, y is positive and x is positive. Or two, the one we forget about, both are negative. So I can have x and y both be greater than 0, and that gives me a positive ratio. Or I could have x and y both be negative. That also gives me a positive ratio. So if we do this one, since it's a little longer, we're going to box it in green. I want the fill in that color. So x and y positive, that occurs in quadrant 1. X and y negative, that occurs in quadrant 3. So I'm looking at 1 or 3. Let's go play my next game. Cosine theta less than 0. Cosine is x over r, which is less than 0. So in order for this ratio to be less than 0, I can only have a single negative. I could put the negative only on the bottom or only on the top, but it can't go both ways. The problem is our hypotenuse is not allowed to be negative, so that tells me my negative must belong to the x value. So x is less than 0. So we go play this. X is less than 0 on the left, so that puts me in quadrant 2 or in quadrant 3. And the overlap winner is quadrant 3. So theta in quadrant 3. Call these 2's clues. All right. Example 4, use the given information to find the other 5 trig functions of theta. So we are given 1, that's why it says the other 5, and then we are given the sign of the other one, meaning positive or negative. So we're playing a 2's clue game here. I did not leave a lot of room in there. Yeah, I added space, and obviously it didn't save my space. So we'll make it fit, and then I'll shrink it up and get it to fit on your notes. All right, so we're going to play the game first. So we need to figure out the winning quadrant, and then we'll worry about a picture. All right, cosine is negative. Cosine is x over r. So I know x over r has to be the ratio negative 5 over 13. What that means, I have a choice on my negative. I can take this negative and stick it on the top, or I can stick it on the bottom, but it can't go both places because that would be a positive. Problem is, remember, r is never negative, so that forces the negative to the top. So if the negative is in the top, that means x is negative. So I know that we have to be, based on this first clue with x being negative, that we have to be in either quadrant 3 or quadrant 4. Then I'm going to go to my next clue. Sine of theta is greater than 0. Sine is y over r. If y over r is greater than 0, because r has to be 0, I know that y also has to be greater than 0. I believe it did not save my space. I'm going to force fit it. Okay. Based on y being greater than 0, I have 2 choices. I am either in quadrant 1 or I am in quadrant 2. And the overlap winner, quadrant 2. So we know our triangle is in quadrant 2. So now what we want to do is we want to go draw our triangle with the 2 sides given, where x is negative 5 and r is 13. Then we can find our missing side. All right, so I'm going to go draw my triangle in quadrant 2. So I'm going to come over here. Actually, you know what? I'm going to shrink this because this doesn't need to be that big. So we're going to go smushy. That's small enough. It's the beauty of an iPad. I can shrink anything how I want to. All right, I'm going to draw my triangle in quadrant 2. So, womp, womp, womp. There we go. So here is, just for a reference, this is the angle theta, which we are talking about. We know x is -5, so I'm going to come down here below. And I know r is 13. We are missing y. So then we're going to use our little Pythagorean theorem with x, y, and r to find y. So Pythagorean theorem, x squared plus y squared equals r squared. So -5 squared plus y squared, I don't know it, equals 13 squared. All right, so again, I'm not going to show all these algebra steps. We should be past that by now. 13 squared, then we're going to move the 25 over. Minus 25 is 144. Y is the square root of that, which is 12. Because we're in quadrant 2, technically we would be assigning a positive or a negative. You assign the sign of y based on the quadrant it falls in. In quadrant 2, y is positive, so that's why we're assigning it a positive value. So I can come up here and put my y in. I'll change the color since that's the one we solved for. All right, so now I have all 3 sides, so I can find the other trig function. So I do mine in order. We're given cosine, so we'll skip that one. So sine of theta, y over r, 12 over 13. Cosine we were already given. Tangent of theta, y over x, 12 over -5. Reciprocal of sine, cosecant theta, r over y, 13 over 12. Secant theta, reciprocal of cosine, r over x, which would be 13 over -5. Notice that does fit what we were given. And cotangent of theta, x -5 over y, 12. Done. All right, like I said, I'll make sure you have more room in these before I upload it because this is tiny. All right, now we're going to magic fit the other one. All right, second one, same game. It's called Two's Clues. Cotangent of theta is -2. Cosine of theta is positive. So we're going to play the same sine game. I'll shrink it down later. All right, cotangent. Cotangent is x over y. So x over y, it's easier to do it in a ratio form, so that would be 2 is the ratio, 2 over 1, with a negative one place or the other. So as far as a negative goes, x is allowed to be negative, or y is allowed to be negative. The only one that's not allowed to be negative is an r value, but r is not involved with cotangent. So I could make just the x negative, or I could make just the y negative, but I cannot let them both be negative. So as far as the quadrant game goes, one of them can be negative, but not both. So that would put us in the diagonals of either quadrant 2, where it's just x negative, or quadrant 4, where it's just y negative. Second clue is that cosine of theta is greater than 0. Cosine is x over r. Well, r has to be positive, so because this is positive, that forces x positive. So x positive would be to the right, which is going to be quadrant 1 or quadrant 4. And the winner is the overlap, so we know our angle is in quadrant 4. So that's where we're going to draw our picture. All right, and we're going to smush. I'm going to smush a little bit. Like I said, I will make sure there's more room, and I'll make it bigger before I upload it. All right, so we are drawing in quadrant 4. So I'm going to just kind of smush it down here. All right, here is my triangle. And as far as the angle we're referring to, that's theta. All right, so for my ratio, here's where we gotta go fix this negative. I've gotta go figure out where the negative needs to go. So based on quadrant 4, the negative needs to go on the y value, which is on the denominator. Don't accidentally assign the x the negative. All right, so x is 2, and y is -1. All right, so that means we're missing r. So r is going to be x squared plus y squared, and always, that is a terrible square root symbol, always the positive square root for r, always. X and y, you got to pick the sign based on the quadrant, but for r, we never do that. So r is, that's 4 plus 1, r is the square root of 5. That's a different color. Yeah. R equals square root of 5. That looks terrible, but it's there. All right, we were given cotangent, so let's go find the others. I'm going to start with sine. I like to go in order. Sine of theta is y over r, so -1 over the square root of 5. Remember, everything got to be rationalized. Move it up and drop it. So negative square root of 5 over 5. Cosine x over r, which one were we given cotangent? So 2 over the square root of 5. Again, you should be getting to the point now where you don't need to write it this way. You can jump immediately to the rationalized form. So that's what I'm about to start doing. Tangent, y over x, y -1 over x 2. And if we kind of double check, that does go with the reciprocal of cotangent. All right, cosecant is r over y. Running out of room. Scoops that up a little bit. So again, they got to be simplified. Negative square root of 5. Secant r over x 2. Cotangent was given, so that's one we can skip. Like I said, I'll make sure you got more room than that, because that is not enough space. And I know I did it. It just didn't update on my iPad. All right, next thing we're going into is a reference angle. So a reference angle, it's important to know that definition. Positive acute angle formed by the terminal side of theta and the closest x-axis. Terminal side of theta and the closest x-axis. Notice it says x-axis. Never go to the y-axis. Always go to the x-axis. Okay. So we'll draw each of these just so you can kind of get a perspective of how it looks. All right, reference angle associated with a given angle. So an angle of 130. Again, I'm just going to put a x and y axis in here. I'm not going to label all the way around. We're just going to go to what quadrant these angles terminate in, and then we'll get our triangle drawn. So 130-degree angle is bigger than 90, but less than 180. So it's going to terminate in this quadrant. Oh no, we'll go here. So here is the angle 130. A reference angle is the positive acute angle. Again, if we go read, by dropping a perpendicular segment from the terminal ray to the closest x-axis. So a perpendicular segment, perpendicular means hit at a 90, to the closest x-axis. So that's going to be our closest x-axis. So this right here is our reference angle, which I'm going to call theta sub r. All right, so if we look at the way this is oriented, my reference angle is going to be that straight angle, 180 degrees, or if it was in radians pi, minus the given angle, 130. So my reference angle is 50 degrees. B, 220-degree angle. So again, all in standard position. 220, moving counterclockwise. 90, 180, 270 is too far, so 220, somewhere around here. So here is the angle we were given. Drop perpendicular to the closest x-axis. There's my little perpendicular ray. So my reference angle is going to be this little bitty one right there. Another thing you need to note, it says a positive angle. Okay, so theta reference here is going to be my angle because it went past the straight angle, 220, minus that straight angle of 180. So if we do 220 minus 180, we have a 40-degree reference angle. So the bottom angle in that little triangle right there. Third one. Right, negative 300. So sometimes it's a little bit hard to think of in terms of negatives. We've got to be very, very careful with those. So I'll go ahead and draw it, and then I'll explain why I'm going to do what I do. So negative 300, there's negative 90, negative 180, negative 270, there's negative 300. So the angle we're referring, whoa, I hit a button. There it is. The angle we were given is technically this angle. That's kind of hard to deal with the reference angles because you tend to make them negative. So I would think in terms of its coterminal angle, which is going to be adding a loop. So negative 300 is coterminal to the angle I get when I add 360 to it. So if we take negative 300 and add a loop, it is coterminal with a 60-degree angle. So rather than referencing that negative 300, I want to go with its coterminal angle, which is the positively rotated 60-degree angle. So I drop my perpendicular to the closest x-axis here. So right here is my reference angle. Notice it's the same. But if you call it the same as negative 300, you're going to get it wrong. One, because it's negative, it's not allowed. And two, because it's not acute. Acute means between 0 and 90. So it's actually going to be the same as that coterminal angle. Our reference angle is 60 degrees. So if you can get it in quadrant 1, it's going to be the same. It's already acute. All right, moving into radians. All right, 2 pi thirds. Again, if you need to go back and label, it is helpful. So I'll label this one just for a quick review. So 0, this is pi halves. This is pi. And this is 3 pi halves. And then full circle, 2 pi. So positively rotated angle. 2 pi thirds, if you convert, 2 pi thirds is going to be, it's not quite pi because that would be 3 pi thirds, but it's not here, it's somewhere in here. So there's my angle. This is the one we're referring to. Drop perpendicular. So our reference angle is going to be this one right here. Man, I'm making these a little small. They are. So in terms of radians now, looking at where that angle is located, our reference angle is going to be found in the exact same way as the other one we found that was in quadrant 2, but instead of using the 180 degrees, we will be using its equivalent, pi. So pi minus our angle, 2 pi thirds, which is pi thirds. And then our last one, which we're going to smush in here as well. So I'm not going to relabel. You've got the reference label on this last one over here. 11 pi 6. So if I go 11 pi 6, we're still counterclockwising. Pi halves, it's bigger. 11's bigger than 6 pi over 6. We keep going. It's bigger than this. 1 rotation would be 2 pi. We're not quite at 12. So we're somewhere in here. So the angle we're referring to is this one right there. So perpendicular drop. So our reference angle is this little baby angle right there. And I don't have enough room, so I'm going to draw an arrow. There ain't no way that's going to go in there. There's my theta r. So in this case, my reference angle is found by taking a full rotation. In radians, a full rotation is 2 pi. And removing the angle from it. If I take a full circle and remove the angle, I'm left with the little pink angle, reference angle. So 2 pi minus 11 pi over 6. If we do the math on that, it is pi 6. right. Special right triangles, so we're going back to those special right triangles once we get these reference triangles drawn. So it says use reference angles and special right triangles to find the exact value of each expression below. So if you've forgotten what those reference triangles look like, remember they are printed in the previous set of notes. So if you need to go back and pull those up, you can go back and pull those up. All right. So first thing we got to do is figure out what our reference angle is. So 330 degrees. So cosine 330 degrees. So I'm going to draw a little quick one here. Oh, I like them in the dark blue. So again, I'm going to go through the angle measures a little bit fast since we've already covered locating where the angles, the quadrant the angles terminate in. So 330 is going to terminate in quadrant 4 here. So our reference angle is going to be found by subtracting from 360. So we have a 30-degree reference angle. So if we finish our triangle off here using our 30, 60, 90 right triangle, opposite the 30-degree angle is the side A. Adjacent to the 30-degree angle is the side square root of 3A. And then hypotenuse, 2A. So cosine is x square root of 3A over r, 2A. A's divide out, and we get square root of 3 over 2. I think this is the last. Yes, last one. Sine of 135. So 135. Here's my little quick reference. 135 terminates, and that's crooked. It bothers me. Quadrant 2, because it's not quite 180, but it's bigger than 90. So we're terminating here. So here is our angle, 135. So to find our reference angle is going to be 180 minus that angle, 135. This is a 45-degree angle. So if we finish our triangle off on the 45s, let me just drop the perpendiculars to each peak. So on our 45s, each leg is A, and the hypotenuse is the square root of 2. So we have an A, we have an A, and we have a square root of 2. But you do want to make note here. Oops, yep. No, we're good. And make note here that, and I should have done this on this last one, let me go back. That's down, that should be negative A, but it wasn't involved in this calculation, so that's why I wasn't really bothering with it. But here, it does help to go ahead and do that. So in this case, because we are in quadrant 2, that bottom leg is going to be negative A. So sine of 135 is the y value, A, divided by the r value, square root of 2. And if we rationalize that, we're going to get the square root of 2 over 2. A. Square root of 2a over 2. Let's put the a at the front, I guess. A. Right. Tangent 210. All right, 210 is quadrant 3. So like here, draw a perpendicular. So here's the one we're referring to. So if we do our math here, if we take 210 and subtract the straight angle 120, we get 30. So this little baby angle, I'm not doing a very good job of drawing them to keep them small. That is a 30-degree angle. So if we reference back our sides, opposite the 30 is going to be A, but it is down, so technically negative A. Adjacent to the 30 is going to be the square root of 3A. It's also left, so negative square root of 3A. My arrow's kind of in the way for that. Here, let me scooch it over. Negative square root 3A. And then the hypotenuse, 2A. Tangent is y, negative A, over x, negative square root of 3A. The a's divide out, negatives also drop. Move the square root up and drop it on the bottom. Square root of 3 over 3. Tan 5 pi fourths 5 pi force. Again, you might need to, if you still are struggling with those labels, and review from the last section when we covered how to get them drawn in the correct quadrant. 5 pi force is in quadrant 3, right here. So we drop perpendicular. Our reference angle here is found by, actually I'll try to get that in there, subtracting our angle, 5 pi force, from the straight angle. And remember that straight angle in radians is pi. So we're going to do 5 pi force minus pi. So we have a pi force angle here. Pi force is equivalent to 45. Okay, so we're still dealing with that 45, 45, 90 triangle. So in this quadrant, the legs negative a, and the hypotenuse a square root of 2. So tangent y negative a over x negative a, which is 1. 4 pi thirds. Four pi thirds terminates in quadrant 3, also a lot of 3s. Here is our angle. I'll try to draw it where I get a little more room. Oops. Perpendicular drop. So our reference angle, if we do 4 pi thirds minus pi, it's pi thirds. Pi thirds is equivalent to 60. So opposite the 60 is the square root of 3a. It's also negative. Adjacent to the 60 is a, and then the hypotenuse 2a. So sine y negative, oops, I forgot my negative on my x, sorry. Negative square root of 3a over hypotenuse 2a. A's drop, negative square root of 3 over 2. F, 5 pi 6. I haven't done that one yet, have we? No. 5 pi 6. Here's my little grid. 5 pi 6 is in quadrant 2. It's less than pi, but not smaller than pi halves. So here's my 5 pi 6. Drop it perpendicular, gives us here. So we get our angle. Pi minus 5 pi 6 gives us an angle of pi 6. Pi 6 is equivalent to 30 degrees. So opposite the 30 is A. Let me go back to pink. Adjacent to the 30, square root of 3a, but because we are in quadrant 2, make sure it's negative, and then hypotenuse 2a. Tangent y, a, divided by x, negative square root 3a. A's divide out, move the root up, drop it on the bottom, and keep the negative somewhere. All right. Special note at the bottom, we are headed to the unit circle in the next. This unit circle is created using these special right triangles, so we will be seeing this again. Go do your homework and let me know if you have any questions.